Previously in the Try Hack Me series. So I'm kidding. In the previous video, we started looking, or I said we were going to actually go through the entire junior penetration test learning path on Try Hack Me, and I'm actually really considering this. So yesterday, I began looking over the pen testing fundamentals, and I told you that it actually took about 5 or 10 minutes to complete this scenario or room, what do you call them, on Try Hack Me. Now today I'm going to look through the principles of security, so I'm actually going to flash forward through this one, and then in the next videos we're actually going to go through this introduction to web hacking. If the level of interest of you guys watching this video is maintained high, I'm actually going to go through it, otherwise not. So for that, for me to actually keep on doing this, for me considering worth spending my free time on actually doing this, you'd better be sharing these videos and hitting the like button. I never asked for that, but I believe sometimes it's worth repeating because otherwise there's no incentive for me to actually do this for free. So, introduction to pen testing principles of security. Let me make sure that we're actually recording here. All right. So the following room is going to outline some of the fundamental. Now, as I'm going to go through this is a side note. As I'm going to go through these scenarios, rooms, or whatever you call them on Try Hack Me, I'm actually going to go and add my twist and comments here and there from my experience, because I know there probably must have been others who've done these videos or these walkthroughs on YouTube already, which is why it would not be worth for me doing them, just repeating the same information and adding to the clutter of information that's on YouTube, unless I add something of my own to this room. So I'm going to try and do that as often as I can. The frameworks used to protect data and systems to the elements of what exactly makes data secure. The measures, frameworks, and protocols discussed throughout this room all play a small part in defense in depth. So this would actually be sort of like blue teamish stuff. Defense in depth is the use of multiple varied layers of security to organization system and data in the hopes that multiple layers will provide redundancy in an organization's security parameters. While I wouldn't think that multiple layers will provide redundancy unless each layer is created and taken care of accordingly, because you don't want to be having security through obscurity. Answer the question below. Let's proceed. No answer needed. That's completed. Wow, what a challenge. The CIA triad, and CIA stands for confidentiality, integrity, and availability, is the opposite of disclosure, alternation, and destruction. DAD. CIA DAD. So the CIA triad, now fellas, bear with me here because this is going to be extremely boring, but for the sake of completion, we have to go through these. Is an information security model that is used in consideration throughout creating a security policy. The history does not start with cybersecurity, but instead applies to scenarios like filling records. So this is what it stands for, and it has become an industry standard, should determine the value of data that it applies, and in turn the attention it needs from the business. This is a continuous cycle. Let's explore these and contextualize them into cybersecurity. So what does confidentiality mean in terms of cybersecurity? It actually refers to the protection of data from unauthorized access. This is really important to know. Organizations will always have some form of sensitive data stored on their systems. So when you're actually testing an application, let's talk about a web application. If you're testing for example, a blog of a company, that's probably not gonna hold a lot of sensitive information in there unless by you leveraging the credentials of the users can migrate or can pivot onto other assets of the specific company. So let's say you have a WordPress blog and you find the credentials of the administrator on that WordPress blog. Sometimes, most times, people use the same passwords on multiple assets. So you can try actually using those passwords to other assets of the company. What I would do in such a scenario would be to actually enumerate and sort of like try to see if you're able to pivot vertically and find as many assets of that company as possible and then try and reuse those passwords. To provide confidentiality is to protect this data from parties that it is not intended for. So from pry eyes. Employee records, accounting documents. So confidentiality will be provided in a sense that only people with given privileges have access to it. Integrity, where information is kept accurate and consistent unless authorized changes are made. Integrity is really important because there have been situations where data has been compromised, databases have been altered, and the maintainers of those databases have not known. So to be able to actually maintain integrity, one of the crucial aspects in cybersecurity is to be able to log everything that occurs with a specific asset. Let's say that you have a web application. One of the ways that you would be able to maintain integrity is to always keep your eyes on the logs, because the logs will tell you. And one of the issues that often occurs in applications and in online assets is that there isn't sufficient logging and monitoring. So with sufficient and appropriate logging and monitoring, you're able to maintain integrity of the specific asset or the data that you're talking about. Availability. In order for the data to be useful, it must be available and accessible by the user. That's quite counter, and that's really straightforward and intuitive. Not counterintuitive, but intuitive. It's very often a key benchmark for an organization. Yeah, for example, exactly what I was wanting to talk about. So a lot of companies actually pride themselves by saying that their assets are 99.99% of the time available, which is really good because you want to have access, as a consumer, you want to have access to something that's highly available all the time. What element of the CIA triad ensures that data cannot be altered by unauthorized parties? So let's try and see if they're talking about integrity. What element, not integrity, but integrity, which comes from integer, which actually means whole. Sort of like. What element of the CIA triad ensures the data is available? Is it confidentiality? Of course not. And then you're talking about confidentiality. This is boring. Now, I've done this one today. Principles of privileges. They talk about PIM and PAM. PIM stands for Privileged Identity Management, and PAM, Privileged Access Management. So PIM is used to translate a user's role, identity management, within an organization, whereas PAM is the management of privileges a system access role has. Okay. A few questions related to that kind of stuff. So this is also finished. Security models continue. Before discussing, let's recall the three elements of the CIA triad. According to a security model, any system or piece of technology storing information is called an information system. Let's explore some popular and effective security models used to achieve the three elements. Well, I'm not really sure. So, as a someone who is very practical, you being a practitioner in cybersecurity, whether you're a penetration tester or a cybersecurity analyst or a cybersecurity researcher or whatever role you might have, I don't think it's good to actually have knowledge of these concepts, but you're probably not going to use them a lot. Is used to achieve this model, Bella Padula model, is used to achieve confidentiality, and it has a few assumptions. So the advantages and disadvantages, this is a lot used in governmental and military because the members of the organization are presumed to have already gone through a process called vetting. Vetting is a screening process where applicants' backgrounds are examined to establish the risk they pose to the organization. Therefore, applicants who are successfully vetted are assumed to be trustworthy. So, the Bella Padula model, government military. BIBA model is the equivalent but for the integrity of the CIA triad. This applies to objects and subjects. You can think of objects as data, subjects as users. No write up, no read down. So this actually means that the subjects can create or write content but can only read the contents of objects above the subject level. So they can create or write content to objects at or below their level but can only read the contents of objects above the subject level. Advantages: simple to implement, resolve the limitation by addressing both confidentiality and data integrity. So you have many layers and things can be easily overlooked. When you would actually test such a system, it would be flawed or maybe full of insecure direct object references, possibly, and issues of authorization, because oftentimes such models or such assets built with this model in mind are custom made, and to actually write everything without making a mistake when it comes to privileges, authorization, and access level, it's quite not easy. Alright, what is the name of the model that uses the rule can't read up, can't read, can read down? So this one is this one, BIBA model, I would say. Answer format: can't read up, can't read down. Can't write up, can't read up, can read down. BIBA model. But why does it say so the format, since this is the format, can't read up, can read down. No write up, no read down. So this model cannot read down, but this one that they're actually talking about, so it would be this one, the Bella Padula model. Just copy paste it. And of course, what is the name of the model? Can read up, cannot read down. It's this one, the BIBA model. If you were a military, what security model would you use? Of course, this one. If you were a software developer, what security model would the company perhaps use? This one. Alright. Bear with me, fellas, because boring is about to be finished. just a little bit more. So let's see how many minutes are we running into here. 15 minutes. Oh my god. Threat modeling is the process of reviewing, improving, and testing the security protocols in place in an organization's information technology infrastructure and services. The threat modeling process is very similar to a risk assessment made in workplaces for employees and customers. So, threat modeling involves preparation, identification, mitigation, and reviews. It is, however, a complex process that needs constant review. An effective threat model includes threat intelligence, asset identification, mitigation, and risk assessment. So there are frameworks such as triad, spoofing identity, tampering with data, repudiation threats, information disclosure, denial of service, and elevation of privileges, STRIDE, PASTA, process for attack simulation and threat analysis. InfoSec never tasted so good. Let's detail them below. Spoofing. What does it mean to spoof? This actually requires you to authenticate requests and users accessing a system. Spoofing involves a malicious party falsely identifying itself as another. So this actually comes as spoofing an identity. Access keys help remediate this threat. Tampering. By providing anti-tampering measures to a system or application, you help provide the integrity to the data. Data that is accessed must be kept integral and accurate. For example, shops use seals on food products. Repudiation. This principle dictates the use of services such as logging of activity for a system or application to track. Information disclosure, my beloved one. Applications or services that handle information of multiple users need to be appropriately configured to only show information relevant to the owner shown. I'm seeing a lot of information disclosure issues in the pen tests that I'm doing daily. Denial of service, everyone knows what it is. Elevation of privileges. Okay, a breach of security is known as an incident. Incidents are classified using a rating of urgency. An incident is responded by a computer security incident response team, CISIRT, which is prearranged group of employees with technical knowledge. All right. 6 phases of incident response: preparation, identification, containment, eradication, recovery, and lessons learned. Probably the most important. Preparation. Do we have the resources and plans in place to deal with the security incident? Has the threat and the threat actor been correctly identified? Really important to know. Containment. Can the threat security incident be contained to prevent other systems or users from being impacted? This is really important when you're dealing with a response to a certain threat. Eradication, removing the active threat. Recovery, perform a full review of the impact system to return to business as usual operations. What can be learned from the incident? If it was due to a phishing email, employees should be trained better to detect phishing emails. Phishing still happens in 2022. What model outlines spoofing? STRIDE? Is it? What does the acronym IR stands for? Infrared? Is it? You are tasked with adding some measures to an application to improve the integrity of data. What STRIDE principle is this? To improve the integrity of data. Okay, so you are tasked with adding some measures to an application to improve the integrity of data. What STRIDE principle is this? So the STRIDE principle that deals with improving the integrity of data. The tampering. An attacker has penetrated your organization's security and stolen data. It is your task to return the organization to business as usual. What incident response stage is this? Recovery, of course. Of the course. Alright, so we finished the principles of security. Finally, it was boring for me. It was probably boring for you as well. But we've done it. Next, it's going to be introduction to web hacking, walking an application. So stay tuned for that.